In this video, we're going to make a dust boot for the Lead 1010 CNC machine for a shop vac with a 1 1/4 inch hose. The first step is to get your model into Fusion 360. There's two ways you can basically do this. It's either design it directly in Fusion 360 or you can import the model in. Once your final model is ready, we select the manufacturer tab in Fusion 360 and we start setting our cutting tools, our feeds and speeds, and once we're done with that, then we'll output our .nc code ready for our CNC machine. Once you're ready to spit out your G code, you hit post process and this window will pop up. There's only a few things that you need to do, and this is my way of doing it. It's worked for me. I'm sure there's better ways to do it, but so far it works. The first thing is under post configuration, you want to select GRBL under the setup. The output folder is whatever you want. The extension should be .nc. Your program name can be whatever floats your boat. I like to use G28 safe for tracks. I like to disable that. And the most important thing on this screen, I think, is set units into millimeters. If you set it in inches, your machine will run wild. They may fix this later on, but this was one of my main problems. I didn't know. And also make sure to check open NC file in editor after you save it. That little checkbox in the bottom left, because that's important too. After you hit post from the previous window, the NC code editor will pop up, and there's a couple things that you need to do or else it won't run through the Open Builds control panel or software. The first one is that line 10 that's on my screen. It can be at a different position, but the main thing is T1 is the tool number you selected, and the M6 is the tool change command. And this isn't compatible as far as I know, and it will, if you leave this into your code, it will throw an error. Your program won't even start. It'll just see an error and stop. So what you want to do is delete this line, and you can leave it blank. You can move all the code up. It doesn't really matter. And then the other thing I like to do is I like to just erase the whole tool change command, and then in place of that I'll add in Z12, and all that does is takes my tool and it raises it a ½ inch or 12 millimeters up, and then it begins the process, the rest of the G code. And all this does is make sure that the head or the tool doesn't drag across the surface of my wood or project or whatever I'm working on. There may be a different way to do this, but this is simple and it's worked for me. But the main part is you need to delete that tool change command. Next, we cut the pieces out of plywood. We are using an 1/8 inch end mill bit. This is a ½ inch piece of wood or plywood, and we are doing what everyone does, is religiously following the bit with a shop vac, the very first few cuts you make. In this next step, we are going to cut our Lexan, and the method to hold it down is I'm using painter's tape, and I apply a layer onto the spoil board, and then I apply a layer onto the Lexan sheet. Then next you take a contact adhesive, or two-part. One is just a glue and one is like an accelerant, and you spray it on the back side of the workpiece, which should have a layer of painter's tape on it, and then you smash it into the painter's tape that's on top of your spoil board. So that should hold your piece together quite nicely for your quick operation. That's an interesting sight. To cut the Lexan, I end up using a single flute 1/8 inch diameter bit, and because I didn't want the Lexan to crack, or I really just wanted the really perfect cut, I went very slow. Since this thing is, the sheet is so thin, it's done in one pass, and I just set it to a very slow cut, and it came out perfect. The only thing that kind of didn't come out perfect was towards the end of the cut, where all the protective sheeting was coming off the Lexan. It ended up grabbing at the very end, spinning like a helicopter, and you can see me jump because it scared the living piss out of me. Oh my god! Wow, look at this. I feel like I can do things now. Mom, look at me now. The next step, I screwed the sides to the top piece, and now I'm getting ready to super glue the small neodyme magnets onto the top piece, and the bottom piece already has them on. And if you look over to the left, they're already kind of on there, so the polarities match. So now I just sandwich this together and then put a weight on top of it like a shooter sandwich. Next step, I start attaching the dust cover fingers, brush, whatever. I bought this off Amazon. It came in just a roll, and I just kind of wrapped it around there and screwed it around the edges, and it holds up pretty good. Here we're getting ready to install the boot. It just slides underneath, and on the open build's spindle holder there's 4 open threaded holes, and all you have to do is slide this up. There's a notch to avoid the LED light kit that I have on mine, and they simply just screw in. It's just 4 screws, so it's quick on and off if you ever need to remove the whole dust boot, but usually I just leave it on, and the magnets I can just take off the bottom section. So now this top section is attached, you can now just slip on the bottom like so, doing this blindly, and then I take our window and it just pops in there perfectly. So I'm really happy that that worked out the first time. And now we turn it on, and now we have a window along with our dust boot. Pretty cool, huh? So I planned for the window to be a friction fit, and it ended up not working very well. It kept vibrating out. So my temporary solution was to hold the plexi or the Lexan window down with some, I think it was number 6 washers and a screw, just whatever I had laying around, and it worked out great. This temporary solution, worked out so good I never changed it. So the brush length I bought was way too long, and they're quite stiff, and they do put some pressure onto the spindle. You could see it flex a little bit, and you know, it was fighting it. So what I ended up doing was assuming there's about a 1-inch depth of cut, lowering my spindle down, and then kind of trimming the bristles at one spot. And it was quite hard to cut. I'm not sure what material this was, but once I get the height that I wanted the bristles to be, I then took off the bottom section and cut all around. So here we have our final dust boot and our our final bristles. I didn't cut them very evenly, although I meant to. That's more because they were very hard to cut with the scissors, and maybe they weren't very sharp scissors, or maybe they were really tough bristles. I'm not sure, but it still works very well. By the time this video has been posted, I've used it. My only complaint is on the X direction, on the left and right towards the rails. I may have lost a 1/4 inch of travel. Not a whole lot, but you know, I was trying to maximize the whole direction of it. So that's not a huge deal. I can just move my limit switch, because when I hit home, it banged into the side. It actually bangs into the rail cart, or the rail plates, but in reality I rarely go that far anyways. Hope you enjoyed this video.